Hi everyone, my name is Sharon Platt. I am one of the science tutors for the Student Success Commons, and this video is going to be about atoms, ions, and isotopes. So you remember in the last video we talked about atoms and we talked about their different parts. We talked about protons and neutrons and electrons and how they're made up there. And that protons have a positive charge, electrons have a negative charge, neutrons are neutral. Alright? We also talked about what happens when you change each of those things. So if you change the number of protons, you actually change the element itself. The protons define the element. So we cannot change those without changing the element itself. Neutrons, if we change the number of neutrons, usually add neutrons, we get an isotope. All right? And we'll talk more about that in a minute. Electrons, if we change the number of electrons in an atom, we get an ion. If we take away an electron or we take away a negative piece, we get a cation, a positive ion. If we add an electron, we're adding negative, we get a negative ion or an anion, because the protons don't change. We're only changing the number of electrons. All right, so let's talk more about isotopes. Now, I made this one up here. I took the helium and just added another neutron, and you really can't see the different colors in there. Sorry about that. But I have 2 red protons and 3 blue neutrons in there, and of course the electrons stay the same at 2 as well. All right, that's what an isotope is. It has more neutrons than it does protons in the nucleus, and some of those are stable and others are radioactive. So for example, if we take carbon, carbon has 6 protons and 6 neutrons normally and 6 electrons. And so the normal carbon we call carbon 12 because of the 6 protons and the 6 neutrons. And that's our regular. About 99% of carbon atoms are the carbon 12. There are, most of the rest of the 1% are carbon 13. So we have 1 extra neutron. We would have 6 protons, 7 neutrons, and 6 electrons. And those are also stable. They don't break down. So the carbon 13 is a little less than 1%. And then a tiny portion of, a little bit of 1% is carbon 14, and those are radioactive. So we still have 6 protons because it's still carbon. In that case, we would have 8 neutrons and still 6 electrons. So only our neutrons are changing. And when you get 8 neutrons in that carbon atom, it becomes unstable and it tends to spontaneously decay and break down. And when a radioactive isotope breaks down, it releases energy, radiation. So these are very useful for various things. Carbon 14 is where we get carbon dating from. There are other radioactive isotopes that are used in medical things, and we have radiation and different things that are used there. So isotopes are very useful. And most of them are stable, but a very small number of them are radioactive. So let's talk about ions. So this is our normal sodium. Na is sodium. And there should be 11 red dots and 11 blue dots in there. I don't know. I tried. And so that's our nucleus of protons and neutrons. Those stay the same in this case, and we're only changing the electrons. The electrons here, we have 2 in that inner circle, we have 8 in the next shell, and then we only have 1 in the valence shell here. Now you remember I said in the other video, the valence shell likes to be full. That's when the atom is the most stable, and so just having 1 in this valence shell, it tends to want to get rid of that 1 so that its new valence shell over here, see, this outer one doesn't really exist anymore. There's nothing in there. And this new valence shell is full. It has 8 electrons in it. Okay? So when that happens, when we give away that one electron, and we'll talk about how this works in bonding later, but if we give away that one electron, we now have Na+. We have a positive sodium cation. And we write it this way. If we had a number other than 1, we would write it this way. I made a mistake there and put a 1 there. We just use the plus if it's just 1. But if we had given away 2 electrons, if this was a different atom and we had given away 2, then we would put a 2+ there. All right, so that's a cation. We gave away a negative electron and we wound up with a positive charge. Now this one's an anion, and we're going to use chlorine for this example. And here again we have all our protons and neutrons. They stay the same in there. And then we have our electrons. We have 2 here, 8 here, and 7 here. So we have 17 electrons total there. So in this case, we have 7 in the valence shell. We're almost full. We just need 1 more to make it full. And so let's say we get an electron from somewhere else, maybe from the sodium. And we stick it in there, and then now our valence shell is full. It has 8. It's happy. It's stable. And so we call this chlorine negative. This is a chlorine ion. It's an anion. And again, we don't use the 1, but if we had 2, we would put a 2 negative. We do it in that order. It looks a little funny at first, but that's how it works. All right, so that is ions. You have your cations are positive charge, your anions are a negative charge. And we'll talk about how those go together in the next video.